Welcome to Jamf Cloud Under the Hood. My name is Tom Crow, and I'm the Senior Product Manager for Jamf Cloud. I appreciate you taking the time to learn a little more about Jamf Cloud across all of Jamf's platform. I have a few other colleagues who will be joining me for this session, who I'll introduce in a minute here. But as an agenda, our goal is to provide you an overview of the history of Jamf's Cloud, some areas of expansion and advancements, and some future platform visions for our cloud. First, I want to go back a few years. The last time we did a similar session was back in 2019, which, if you can believe it, was pre-COVID, if anyone can actually remember back that far. At that time, we just talked about Jamf Pro's cloud, as that was the majority of our cloud footprint. But in part of today's session, we'll talk about Jamf Cloud for many areas, including Jamf Pro, Now, School, Secure, and Protect. A lot of expansion over the past couple of years. A few highlights have been called out regarding our cloud services above, but overall, we are focusing on providing a secure, reliable, and stable cloud environment for our customers. As the last bullet point says, leave the infrastructure to us so you can focus on helping your organization succeed with Apple. On this slide, we show our Jamf Cloud global reach. Back a few years ago, we didn't show this map as there have been just a couple of dots on the world map. Today, our complete footprint across our products reaches 16 different regions, and we are continually looking to follow AWS's lead and expand our global reach to meet our customers' needs. Before introducing some of our other speakers for today, I'd like to call out a quote from Michael Kren, our Senior Director of Cloud Engineering. This quote was back in 2016 about our DevOps practice around continuous delivery and building, testing, and releasing far more frequently, and also ensuring that we can release reliably at any time. This has been something we've been continually worked to improve and refine, which is a good segue to introducing the rest of our cloud panel, who will be doing a deeper dive into various cloud areas within Jamf. So with that, I want to introduce our panel. First, we're going to have Peter talking about Jamf Now. We have Andy talking about Jamf School, Robin talking about Jamf Protect, Enrique talking about Jamf Secure, and Brandy talking about Jamf Now. And without further ado, I'm going to pass it along to Peter.
My name is Piotr Kulbiński, and I'm a Senior Site Reliability Engineer for our Jamf Now product. I'm excited to talk to you a little bit about cloud within Jamf Now. I'd first like to touch on our fundamentals plan, which you might already be familiar with. This basic plan allows small to medium-sized businesses to manage their devices in a user-friendly and simple way. It goes beyond that. With fundamentals, one can secure devices using Jamf Protect with just a single click. The rest is on us. Let me tell you about investments we made within the cloud to get there, how we changed our architecture, tech stack, and processes to get where we are right now. Back in the early days of Jamf Now, the release process was performed manually. Code was cut, artifacts were built, then someone with proper access rights had to SSH into EC2 instance to deploy new WAR files to Tomcat. Schema changes were also applied manually. The whole process was cumbersome and long. With project development expansion over multiple teams and geographical locations, that process had to change. Step by step, we started to take ownership of build, test, deploy, release, and maintain processes. This led to a lot of investment in our cloud architecture, and the changes spanned across multiple areas. At first, we tackled build process improvements. Then we made preparations for EKSGA. Once made available, we were ready to use it. Along came automation of Jira-related processes, which allowed us to focus on release and not on shuffling cars on boards. We then made further investments by going down the microservice path. In the end, we ended up somewhere in between because our services are not actually micro, they are single feature oriented. However, instead of freezing new feature delivery in order to focus on splitting monolith, we decided that all new features will be delivered using that approach. As we added more and more services, we were able to reduce monolith code base size without significant dedicated efforts. One of the biggest game changers was introducing feature flags. This allowed us to roll out features selectively and receive feedback before making it generally available. This also allowed us to perform A/B testing of UI enhancements or dynamically change logging level on a per-tenant basis. Words may not be reflecting the amount of work that was required to get where we are today. Maybe this diagram will help. In red, you can see elements that were in place when we started our journey. The rest was added. All those cloud infrastructure improvement efforts allowed the Jamf Now team to go from 26 bi-weekly manual releases to over 500 fully automated deployments a year, making feature release business decision completely decoupled from code deployment. Thank you for spending a little time with me today to hear how cloud improvements have helped Jamf Now drastically increase the number of releases we can provide to you, our customers. I will now pass it over to Andy to talk about Jamf School.
Hi, my name is Andy Mackay. I'm currently a containerization architect at Jamf, but up until very recently, I was assigned to Jamf School as a systems reliability engineer. And I'm going to go through a little bit about what's changed in Jamf School over the last few years. So Jamf School was first launched in 2019 when Jamf purchased Zillow. It has purpose-built teacher, parent, and student applications, and we added safe internet for content filtering this year, very recently, ready to go for the summer holidays. Originally, this was physical hardware, only available from European data centers. We have shifted this to a containerized system running on Kubernetes in AWS. And where possible, we have adopted Amazon managed services for the backend infrastructure. So, for example, we're using their services for queue management. We're using their services for managed Kubernetes. And post-acquisition, we have expanded from offering just in the European region to both the US and Japan. So a little about the service. So Jamf School currently is 15 microservices. It deals with around 350,000 requests a minute at peak time. We release multiple times a week. Each microservice releases separately and has little effect on the others. And in the 3 years since Jamf acquired Zillow, since Jamf launched Jamf School, we have seen an approximate 10 times scaling in the number of devices that are enrolled. Most of this due to or aided by the adoption of cloud services, AWS managed services, etc. So the enhancements that have happened over the last year or so, we have changed so we are now able to make infrastructure changes without downtime. Previously, we would have scheduled a maintenance window with customers and then made changes to the infrastructure, took the system down, etc. Now we do this, zero downtime, again, because of these cloud services we're using. We've separated UI and device traffic at the infrastructure level using Kubernetes ingress so that a surge in device check-ins and device traffic doesn't affect the use of the UI. We have gone heavily into auto-scaling. Because the whole system is running in containers, we have a small number running all the time, and we rapidly scale up and down as traffic grows. One thing that's happened pretty recently is we've been working on scaling the backend database, and we've implemented a system where we can split queries. We can split read queries from write queries. Because we use AWS Aurora, we can have read replicas. So now we can horizontally scale our databases. Likewise, for last summer, we worked on scaling our ability to send APNS messages. As you can imagine, we send lots of these. So we moved from hosting our own queue system inside our clusters to an Amazon managed service for RabbitMQ. which allowed us to massively scale the number of messages we can handle with. And we scaled up the amount of pods, so we can now send way more messages much more quickly, meaning you have to wait less time for things to happen on your devices. There's lots more to come, more microservices, more enhancements, more scalability changes, but that's a very quick run through of what's happened since 2019. Thank you.
Hi, I'm Robin Miller, and I'm a principal software engineer for Jamf Protect. Jamf Protect is next generation endpoint security, built specifically for macOS. It's still quite a new product, launched less than 3 years ago, but even in that short time, its feature set and capabilities have grown enormously. And customer growth and adoption has been great as well. We actually launched at JNUC in November 2019, and I think at the end of that month, we had 4 customers. I'll be told I can't share exact sales numbers, but I can say that today we're well into the thousands of customers. Security represents 18% of Jamf revenue, and that definitely isn't the growth chart hiding in the lower right down there. So, of course, a big selling point of Jamf Protect, and one you're likely to have heard about, is that it's a cutting-edge security product that is macOS native, designed from the ground up for macOS. And I think most people at JNUC have a sense of what that means and why that's good. It isn't a port of a Windows product, but rather it was conceived, designed, and built for the Mac. But what isn't well known, but which is also key to Protect's ability to rapidly iterate, respond, and scale, is the fact that it's also cloud native, conceived, designed, and built for the cloud. And that's what we'll talk about here today. So, cloud native, what does that really mean? To start with some perspective, I think there have been 3 big transitions in the last decade or so to how applications are hosted. And related to that, IT and software development have been on a collision course as the line between the two gets fuzzier and fuzzier. For those 3 transitions, first, we went from physical servers to virtual machines, and soon we also had VMs in the cloud. And then the second wave was containerization and container management, which offered more efficient ways of packaging up a service, but in a way that looked familiar from the inside. The service doesn't know it's not running on a traditional OS. Before I talk about the third step, I want to go back to that other thing I mentioned about IT and software development being on a collision course. During this time, another change was brewing, where IT was changing more from something done by hand to something done via code, often with dedicated languages for defining infrastructure as code. Initially, this was mostly limited to internal server configuration, but as we went to VMs, to containers, and especially into the cloud, it became possible to define more and more parts of a service's infrastructure as code. IT was becoming a lot more like programming. So back then to transition number 3. As I see it, this is the big break from containers and what came before, and that is the transition to serverless. With serverless, there's no more OS, no long-running server software to run your application. You write pieces of code to be executed directly by a cloud service that runs each piece of code in response to some stimulus called an event. It's a break from the past because, for the most part, it requires your application to be written for this paradigm from the ground up. The most famous of these serverless technologies is AWS Lambda, and the events can come from just about anywhere in the cloud: IoT devices, API calls, queue and notification events, just to name a few. The individual pieces of serverless application code, the supporting resources like databases and networks, the relationships and connections and triggers between Lambda and all the other services can all be defined in one place. You can go from nothing to a fully deployed stack of infrastructure running a production application, all with code in a single Git repository. And so this is where I think there's that singularity moment between IT and software development, where suddenly they are one and the same. You write your application, and specifying where and how it runs and even how it deploys itself is just another part of it that you write. So what does this look like? A serverless application is both easy and hard to visualize. Easy because there are often cute little icons for each service, and those relationships lend themselves to diagramming, but also hard because a lot of the complexity can be there and it can end up in the diagram. So what we have here is my attempt to draw a cartoon version of Jamf Protect in the cloud. It's not inaccurate, it just condenses a lot of things down to a few and ignores all but the key functionality. To give a sense of that, there are actually 43 separate Lambda functions, at least as of this morning, represented here by 3. And I think this gives a better view. So what's actually happening here? On the left side, we have the computers running the Jamf Protect agent. They're in communication with Jamf Cloud, sending and receiving encrypted messages, which are handled via the IoT core service. From there, they can take a couple of routes depending on what they are: alerts, telemetry, basic computer information. One route, the top one, is into long-term storage in S3. S3 is great because you can hold a virtually unlimited amount of data and still do things with it, querying it or triggering further activity, like sending it to customers who want it. And the other route below is via an SQS buffer and Lambdas into our main relational database, which not only allows customized responses back to computers, but also makes alerts and other information available for immediate in-app access through the admin web console. So that gets us over to the right side. The admin web console web app running in a Jamf Protect admin's browser, interacting with Jamf Cloud via our GraphQL API. So why go cloud native? Well, I've been talking up cloud native architecture already, but this slide lays out some more things. Because of that singularity between infrastructure and application, development and deployment time can be reduced, especially when a new service or resource is needed. You don't need to figure out how to install, secure, and deploy it or wait for some other team to do that. You just define what you need it to do and write the code to start using it. This also helps with testing because everything is code. You know your dev, stage, and production environments in every region are the same. Cost is another benefit. I think the best illustration is that our highest operational cost is for data storage. Number one is Aurora database clusters, and number two is actually logs. Compute cost is under 3%. And that's not because there's not much going on. At peak times on weekdays, we process, react to, and store over 10 million customer-generated events per hour in a single region. And the final point kind of circles back to the theme I've been on about, in that this allows for true full service ownership. The same engineers design, code, deploy, and operate Jamf Protect in the cloud. There are no fences to throw things over, and it makes for a tight feedback loop with a built-in incentive to fix bugs. So it definitely wouldn't be honest to claim that everything is perfect, nor has every decision we've made turned out to be the best one. And by no means am I implying that you have to go this route to build a good and reliable service, as many of Jamf's other products demonstrate. But I put 4 things up here, which I've tried to make general, but they all come straight from actual challenges and pain points we've struggled with over the last 3 years. The first 2 are the flip side of those benefits of full service ownership. There's no one else whose responsibility it is to fix things when stuff goes wrong. And I have to admit, there have been times when I wish there was. The second one kind of refers to 2 things. First, it's those responsibilities, coding and DevOps and Ops. It takes time and there are new skills to learn. And new management and new engineers need to internalize that. It's different from the traditional approach. But also, it refers to how the ease and simplicity with which the cloud lets you adopt new services and features can be a double-edged sword. The services might be reliable and slick to use, but you can find yourself handling a whole plethora of different things and creating new kinds of complexity that you have to keep track of and understand. Responsibilities that might have been more distributed traditionally. And the last 2 points are kind of about planning and scale. We've been lucky enough to have had to scale quickly, but on a couple of occasions, decisions and features that seem perfectly reasonable at a certain scale have bitten us as we've grown. Without going into too much detail, some of the capabilities we've given customers in the product have given us some real challenges as our architecture and underlying technologies have needed to evolve to ever larger scale. And I think the best one can do against that is to always try to think hard about the implications of feature design decisions when things will be 10 or 100 times bigger. It's a good problem to have, but it's also a genuine challenge. And that's my overview of Jamf Protect in the cloud. Thank you. Over to Brandy.
Hey, thanks, Robin. Hi, friends. I'm Brandy, and I am a manager over in cloud engineering, and I'm going to be talking about Jamf Pro today. In the Jamf Cloud environment, node architecture was built so that we could reduce outage impact because we could limit the blast radius to a single node. Nodes could be sized based off of their utilization, and when our customers require more resources allocated to their environments, we were able to accommodate it and limit it to a single node. Our node architecture has been battle tested, and we have been able to exceed nearly all of the cases of our SLAs. We were better able to manage our server environments by deploying new servers with updates and then decommissioning old servers. And we've moved away to managed services, leveraging Elasticache, and then scaled these environments 30 times larger in less than 5 years. Jamf Cloud was launched before Kubernetes was available. So we had Jamf on Demand and containerized instances for our internal training courses. However, Kubernetes solved many of our scaling challenges that we were having. So when COVID hit, we needed a way so that our educational services could spin up what they needed for training courses, which were now all virtual, and then decommission them easily. We needed to take advantage of what Kubernetes could help us solve. So we started on projects Atlas and Orion to meet these needs. So Orion, the mythology only loosely applies, but think of Orion pointing its way to a target in the cloud. Basically, Orion is Kubernetes adapter for Jamf products, including Atlas. And Atlas sends tasks for Orion to perform on EKS clusters. And then Atlas. So Atlas is the Titan who's holding the dome in the sky and keeping the constellations moving. Atlas is our orchestration service that creates and manages Jamf Pro deployments across multiple accounts and regions. And since it's architected using microservices, we can independently update and deploy specific components. If more capacity is needed for the deployment, they get provisioned, and then that time they get provisioned without anyone having to do any manual intervention. For those of you who might be interested in joining a session for the on-prem Jamf Pro instances moving to Jamf's Cloud, there's another session that's of interest, which is called What's New and Why You Should Migrate. And that is on September 29th at 1 Pacific time. So you could also check into that one. But to highlight, the move from on-prem is pretty straightforward, and generally it takes under 4 hours to complete, and our customer service team is here to help. Before wrapping up, I also wanted to call out the Jamf Pro Cloud-related enhancements that were recently released. These both can be accessed via Jamf account, and the first is related to upgrading your Jamf Pro instance within the cloud. Traditionally, you may have seen notices that your Jamf Pro Cloud instance would be upgraded on a defined date. We're now allowing customers the ability to select an upgrade time ahead of the mass upgrade schedule to customize your upgrade time. And this is different from the premium feature that allows you to defer to your upgrade to a later time. And then the last Jamf Pro Cloud related enhancement that was recently released that I'd like to note is onboarding a new instance to Jamf Pro. This can also be accessed via Jamf account and relates to customers who are potentially new to Jamf Pro or Jamf Connect. Customers have provided feedback. The initial setup process often took some back and forth planning, and so we've automated this through Jamf account and their Jamf Pro and or Jamf Protect instance name when onboarding to Jamf's Cloud in a nice new wizard feature to help streamline this process. Now I'll pass over to Enrique, and he can provide a cloud overview of Jamf Secure.
Thank you. Hi, everybody. My name is Enrique, and I'm director at Jamf Security Cloud. And today I wanted to introduce what's the latest addition to the Jamf product portfolio, which is going to bring threat defense, data policy, and private access. What happened is the Jamf last year acquired a company called Wandera. That company was founded quite a few years ago now in 2012. Today I'll tell you a little bit more about how we adopted Kubernetes in 2018 and how that transformed the way we were building and shipping products. Later on, we launched private access, which opened up a completely new market for us. And as I already said, we were acquired last year by Jamf. What's exciting about 2022 is that a few months ago, we launched Safe Internet, which meant the first major offering that combined what Jamf was always very good at, which was management of devices, together with the addition of our security capabilities. As I already mentioned, our biggest transformation came in 2018 when we adopted Kubernetes as our delivery platform. It wasn't a simple transformation. It did take 2 years from the inception until we migrated all our microservices over to the new Kubernetes platform. It allowed all the teams to ship their features to production much faster than ever before, and it, more importantly, closed the feedback cycle with our customers. So I gave you some numbers there, but we used to have a release train where we would ship a bunch of new features to production once every 2 weeks. And thanks to Kubernetes and a few other changes that we made, we were able to release tickets to production within hours. And that was a big cultural shift as well for us. My colleague already has mentioned about how ownership is transformed when you start adopting these new, technologies. I said new, but they're not new anymore. But it means that you go from an era where you had developers building software and then handing that over the fence to a team of operations engineers who will then deploy to production. We broke that barrier, and then everyone had to learn a little bit about what the new world meant for them. But as well as the benefits when it comes to releasing software to production, we also gain an enormous amount of stability with the new platform. We were always very careful with our releases, but by adopting Kubernetes, we truly entered the world of zero downtime releases. And and reducing the risk of something being shipped to production that would bring down part of the platform. So on this slide, I want to introduce a little bit how the architecture looks like. We developed the product to be multi-platform. So of course, we support every Apple device, but we also support mobile and Android devices. Our software is deployed over 20 edge data centers around the world, providing low latency and localized content. That's very important for us. We want to be as close as possible to the end device that we are protecting and managing. We are cloud agnostic. So those 20 edge data centers are deployed across 5 different cloud providers. This was always very important for us because it was important to have the ability to move fast and deploy our services wherever our customers were located. And sometimes that meant using cloud providers that we didn't have support for in the past. We're 100% cloud-based, and as I've already mentioned, we moved to Kubernetes a while ago. So we now have a Kubernetes cluster on each one of those 20 edge data centers, and we always build it making use of every single availability zone inside those cloud providers for stability and reliability. The team is made up of more than 30 cloud engineers, and we always like to say that all of those engineers bring 5 clear pillars to us. First, Linux. Second, Terraform, which is the language we use to declare all our instances. Third, Kubernetes. I've said Kubernetes way too many times in this presentation, but it is key to us. Fourth, networking. Because of what we do, it is very important that all our cloud engineers are very well versed on anything related to networking. And lastly, public clouds. We are 100% cloud-based. We need to have the ability to move wherever our customers are, and that means leveraging all the different cloud providers available. And that's it. So thank you, everybody, for your time and for listening to our presentation. I believe there is now time for some questions. So yeah, once again, thank you so much.